number 40, January 30th, 2024. And we are happy to have Bill Kennedy joining us today from Miami, Florida. Please take it away, Bill.
Well, thank you for everybody hanging out with me. This talk takes about an hour. I'll keep my eye on the clock. There's a lot I want to share with you as we go through it. I have a second window that's above me, so that's why if you see me looking up, I'm looking at all of you. I also have the chat window up there. So if you have a question during the talk, just type it into the chat. I'll see it. Either I'll tell you I'll answer it when we're done, or I'll try to answer it in stride if it's within context. Also, if things are not large enough for you, just punch a message in the chat. I'll do my best there. All right, with all that being said, everybody hopefully can see my screen. I currently have the repo, ArdenLab/service repo. This is the code base that I use to teach software design with Kubernetes. This is really focused in Go, but I think for those of you who've taken my classes before, a lot of what I teach can be extended outside of Go, and there's no difference here. Material I'm going to talk about over the next hour is material I do cover in my software design class. That's like a 20-hour class, and we tend to get to this by hour, 15. So much to talk about before we get here as well. But I'm going to share with you what I call domain-driven, data-oriented design. Now, there's lots of talks and books out there about domain-driven design. Notice I didn't call this domain-driven design. I'm calling it domain-driven, data-oriented design. And everybody's got their thoughts and ideas about this. So before I jump in, I just want to share a few things with you just to kind of get your minds in the right place, okay? For me, architecture is about your ability and your team's ability to maintain mental models around the code bases that you're building and to be able to wrangle complexity. Complexity kills. And so everything we do has to be around mental models and trying to reduce complexity. Now, I want to be clear. You can't make a complex problem simple. That's why we call it complex. So this isn't about saying that I could take any complex problem and simplify it. That's ridiculous. But it's quite possible to take a complex problem and make it more complex. In fact, we do that all the time. And so what I want you to think about this talk is not, well, Bill's working on simple stuff. No, it's about, let me think of the problems that I'm working on. I know which parts of that are really complex. Am I making things more difficult for everybody, or am I doing things to help people better understand and to wrangle that complexity? So architecture for me has to serve those purposes. This isn't the only architecture that can work, but it's one that's working for me. Another problem I have with any talks around domain-driven is usually it is surface level. It doesn't come with good coding examples. It doesn't come with what I would call production level code. This code here is production level code leveraging aspects of domain-driven design with really, from my perspective, data-oriented design. I'm gonna break all this down, I promise you. And though we only have an hour, I don't have time to go too deep into the code implementation. The code is there. Again, it's all there at ArdenLab's github.com ArdenLabs service. So you can drive into this. And if any of this piques you even more, all this stuff is on video from beginning to end. The job of the class is to give you a full mental model of this code base, its architecture, because this is the code base and the architecture I use for any client project that I'm working on. Now, one last thing before we start. If I'm working on a personal project, it's just going to be me. I'm the only one that's ever going to maintain this code base ever. I probably will minimize, if at all, use any of the domain-driven aspects of what I'm going to talk about. I think that ends up adding too much complexity to the problem that we're working on. So be aware of that, right? Not everything I'm going to share today, I think, deserves to be in every single project that you're working on. That being said, if you're working on a project that's team-based, and this is code that needs to exist after you leave, then I think these are things you want to consider or at least start thinking about. I always say this, you may have heard me say it before. The worst thing that you could ever say to a software developer is that I hope when you retire, not a single line of code you've ever written is having an impact anywhere on the planet. And I promise you that's going to happen to you if you're not thinking about, can somebody maintain this code base when I leave? Because the moment somebody says I can't, they throw it away and they rewrite it. I've been on that side where somebody's left and I've rewritten everything they've done just because it's not maintainable. So I want you to have those ideas in your head as we talk about this. Mental models, making code maintainable, not just by you, but by others and people you haven't even met yet, all right? So this product can continue to exist even when you're no longer working on it. Okay, now from an architectural standpoint, for me, there's three things that you have to have. Let me say that. There are three things I'm going to share in terms of architecture. Two of these, for me, is an absolute must. Even if it's a small project, you need to have two of these aspects. The third aspect is going to be the domain-driven. And again, you don't necessarily need this for every project, but for the ones that are big, the ones that are team-based, the ones that need to exist beyond your existence, I think you need this or something like it. Now, I found this great plugin if you haven't found it already. And what's great about this plugin is that it gives me a working whiteboard. And if you've ever met me, you know how much I love whiteboarding. So we're gonna do some whiteboarding here. And again, we only have about an hour, so I'll show you small aspects of the code where I can, but understand that everything I'm showing you has been implemented. Okay. Aspect one. Back in the year 2000, Brian Kernighan. If you don't know who Brian Kernighan is, please look him up. Brian Kernighan is, I believe he worked at Bell Labs. Rob Pike knows him. Rob Creamer knows him. Ken Thompson knows him. The founders of the Go programming language know Brian. So when Brian says something, I feel pretty confident that the three of them at some level agree. Anyway, Brian was interviewed in the year 2000, and Brian was asked this question. Everything here is going to be paraphrased, but if you want the actual question in quotes verbatim, just ask me. I'll send you that information. But this is close enough paraphrasing. Brian, what do you think is the biggest shortcoming of the C programming language? It's a super interesting question. And if any of you have worked in C before, your brain is already sort of chugging away. What is Brian going to say? What is Brian going to say? What does Brian think is the biggest shortcoming of the C programming language? Well, here's in the essence of Brian's answer. I think the biggest shortcoming is that the language doesn't provide enough firewalls to protect the different parts of your program. And it's not that you can't simulate object-oriented programming or something like it. You can simulate this, but the language and the compiler is not there to help you. My brain exploded when I had read that answer about 10 years ago, that the language is not providing enough mechanisms to create firewalls between the different parts of your program. This is a huge piece of Go. And Go does this with the concept of packaging. And it's really one of the hardest things for a Go developer to wrap their head around when they first start to learn the language. You have to appreciate that prior to Go creating this concept of packages, we were writing monolithic code bases. I was coding in C and C++ and C# prior to Go. And the project, that GitHub repo with all that code in it, that project was basically, it was a monolithic piece of code. We used folders to organize code that we were writing, hopefully to help maintain a mental model. Go has changed the entire thing with packaging. Now, every folder represents a static library. It represents an API. It represents a piece of your program that can be firewalled between the different other parts of your program. This is enforced. And so it took me a long time to start thinking about how do you organize and architect code with this concept of packaging. Took me a long time. If you're struggling with this, it should be because you haven't had any training. Now, in a regular class, I would be spending a lot more time into package-oriented design and type systems and how we're supposed to be thinking about this stuff. We don't have time for that in this talk. We can kind of skip over it because I want to get to the next level. All right, so the first level is having a deep understanding of package-oriented design and understanding how that creates firewalls between the different parts of your program and how to effectively design software using packages. You got to have that. I don't care what the project is, small or big, you have to have that. But assuming that we've talked about that, the next thing that you need to have is what I'm going to call layers. Your project, your architecture has to be built in layers. Now, the question comes, well, how many layers, Bill, right? So there have been studies throughout the years, and I've got links to 2 of them. And essentially, both studies came to the same conclusion. The average person cannot maintain more than 5 things in their head at any given time. 5. 5 is the magic number. So if you work with me and you look at this code base, you're going to hear me always talk about the rule of 5. At no point do we want somebody to have to think about more or understand more than 5 things at a time, because once we do, we're failing them. We're failing the project, we're failing the architecture, we're failing the people that have to be on the project. So we've got to have a rule of 5, which means that the most layers we should have in our project is 5, at least at the outer layer. And then a layer can have layers, that's fair, but again, should never have more than 5. You maintain this rule of 5, you're allowing people to be able to maintain a mental model. Now, I love 3. 3 for me is the magic number. We have the rule of 5, but if you can keep things to 3, really, really helps somebody's brain. Now, I'm going to share the layers that we have here, and part of the conversation is going to be about these layers. But what's important about layers is that layers define policy, they define rules, they define purpose, and it's how you're going to know where a package needs to live and what that package is allowed to do, what that package is not allowed to do. You gotta have these rules, these policies, and it's all part of that architecture. Now, if you were to look at this project here, you would see that there are 5 layers, the outer core of the project. But really, from a coding perspective, there's only 3. You'll see app, you'll see business, and you'll see foundation. Foundation here is what I consider the standard library for the project. Vendors, all third-party code, and Zarf is a fun word where we put all of the configuration that we've got to maintain and manage for the project. Now, from an architectural standpoint, however, these are the 3 layers that are part of this project, and I think would be part of just about any project you're working on, big or small. I want to lay that out now because our talk is going to be around these layers here. So for me, at the very top of your architecture, you're going to have what I call the application layer. The application layer is where your applications are, and there's purpose there. The purpose of the app layer, the job of the app layer is for application startup and shutdown. It's also responsible for receiving external input, then calling into the business layer, which is the next layer here, for processing the business rules. Then after the business layer is done and responds back, the app layer is then responsible for sending out that external output. Now, I want you to think about a couple things here as I'm describing this idea of the app layer. Job is to receive external input, validate that input, call to the business layer, and then formulate a proper response. I want you to think about any line of code you've ever written in your life. Think about any line of code. I don't care what the programming language is. I want you to realize something. That line of code can only do one of 3 things. Only one of 3 things. It can either allocate some memory, read that memory, or write to that memory. This is what your code is doing. It's always doing one of these 3 things. I don't care what the programming language is. Allocate, read, and write. And You want to take it to the next level. This is mind-blowing to me when I think about it. You're only allocating reading and writing numbers, integers or floats, but numbers. That's it. And we're talking to each other over the ocean right now because of code's ability to allocate, read, and write numbers. Now, we talk about these operations being or having integrity when we could say that these operations are done efficiently, consistently, and accurately. All right, that's that level of integrity when we have to do that, and we have to do that. Okay, but I want to step it up one bit. I want you to think about any program you've ever written, any program you've ever written. I want you to realize that your program only does one thing: performs data transformations. There's always some input, you transform it, and you return that output. It's the same thing with your functions, right? Your functions are just data transformations. You are all data scientists, regardless if you use fancy ML and AI models. Forget about that stuff. That part of the industry sort of took over as data science. No, you are a data scientist each and every day with every single function you write. In fact, if you don't have a data transformation to perform, you don't have a need to write a function. I want you to put that in your head because these are the aspects of data-oriented design. Packaging plays a big role in data-oriented design. These layers, as I'm going to show you, play a big role in data-oriented design because everything we do is about data. It's input, transform, output. And so the job of the app layer is to receive some external data, transform it, and well, get it, validate it, pass it to the business layer, then it can transform that response back to the caller. Now, the business layer's job is just to do that. It's to process business rules against that data. Whatever the business rules are, whatever the problem you're trying to solve, that's what we do in the business layer. Now, there's one more layer, 3, that I think most applications are going to have. And that layer is the storage layer. The storage layer. The job of the storage layer is just that, right? It's for persisting that data and being able to retrieve that data. These are the 3 layers that almost all of my applications have. In fact, the only one it wouldn't have is maybe a storage layer if we're not going to deal with any sort of storage persistence. All right, these are the layers. You can name these layers anything you want. Naming is hard. But whatever you name them, they should sit on top of each other in that alphabetical order. And inside the project, you should have that same sort of top-down sort of naming convention. That's why you see here app and business. You see the layering on top of you. You see core business packages that have storage packages, and everything is sitting on top of everything. It really helps around your mental models to name things in a way that visually you can see the layering. It's going to help with your policy making. It's going to help in code reviews. It's going to help with all of that. Okay. Before we continue down this path, I want to take a quick left turn here for 1 second. For many, many years, I would say up till about 3 or 4 years ago, I had a philosophy called no trust. The idea of the no trust philosophy was that no layer, like the business layer, can nor should trust the layer above it, in this case, the app layer. The storage layer should not trust the business layer, shouldn't trust any layer above it. Why? Because data integrity is so critical to everything we do that if the layer above doesn't do its job, I don't want to be dealing with bad data in, bad data out. And I had this philosophy for a really long time. And when you have systems that maybe only have about 10,000 people on it, this works incredibly well and it's fine. But over the last 5 years, I've started working on systems that really are dealing with millions of people. And so this idea of no trust starts to break down. Now, I'm going to share with you why it breaks down now, but understand that we still got to find a way if we're not going to trust, to at least validate that things have been properly checked. But let's quickly talk about what happens when you have this concept of no trust in a system. So imagine this is some sort of request and a piece of data just came into the app layer. Now, I told you the job of the app layer is to validate that data before it passes it into the business layer for whatever that is that it's got to do. Now, imagine that part of the data validation is hitting a database. Just forget about how that happens for a minute. But the idea is that you've got to hit the database to do some data validation. Maybe this is a delete and you want to validate the user exists. Maybe it's an update and you need to get a copy of the data before you can do anything. So you can imagine that the app layer, as part of its validation mechanics, has to hit the database in some form or another to do its validation. And now let's say that it has done its validation. This is just one request, by the way. So what happens? Now it makes a business API call, passing that data into the business layer. But remember, the business layer says, I don't trust the app layer to do its job. And so the business layer goes through all the same validation checks, including, unfortunately, hitting the database. Now, this can get actually worse because there's nothing stopping a business layer API from calling another business API. And that business API doesn't necessarily know that it's being called from already inside a business. And since it doesn't trust anything, it hits the database too. Now, eventually, we get to the storage, but remember the storage layer, it doesn't trust either. And because it doesn't trust either, it goes ahead and hits the database one more time, even before it does anything. This is one request. Look how inefficient this idea of no trust can become. And this is just 3 layers, which is what I try to maintain. You're adding more layers to your architecture. This is happening at even a greater scale. So this idea of no trust has to go away. But that doesn't mean that the business layer should be just taking data blindly from the app layer. When the business layer receives this data from the app layer, it must have confidence that the validation has taken place. And ideally, the only way you can get that confidence is not at runtime. This confidence has to come at compile time. Because if it's at runtime, then you're basically saying, I don't trust you, and you have to check it. And so the question becomes, how do we get the compiler? It goes back to the packaging, right? How do we create firewalls and enforce it? How do we get the compiler to guarantee that this data has been validated as it moves from layer to layer? It's a critical part of your architecture. I'm going to show you in the code here mechanically how we do it. And it's done, or it's driven through a type system. So in this architecture, what we do is every layer has for itself its own data models that it works with. You really need this anyway. The app layer is receiving data, business layer is receiving data, storage layer is receiving data, and we really want each of these layers to have their own data models. Now, your first thought might be, Phil, isn't that a lot of duplication? I'm going to say no, because the data is going to be shaped differently depending upon where you are, and you need that sort of flexibility in the data to be able to isolate code changes across your entire architecture. And ideally, if we don't do these things, then the cost of not trusting is worse, right? Look, at the end of the day, if you want integrity, it costs you a little bit of performance. Go does this already. Think about it. Think about the concept of zero value. Every variable that you construct is at least set to its zero value state. I mean, you got to send electrons through the machine to make that happen. It's not free. Go quite a bit chooses a tiny bit of performance for integrity. And that's what I'm asking you to do here. We're going to take a little bit of performance, but we're going to get integrity. In fact, we're going to gain performance because now by doing this, layers can trust the layers above that they've done their validation. And again, you're getting that validation because the compiler will not compile this program unless that validation check actually has happened. How do we do that? Let's take a look at the user side of this code base for a second. This is the app layer code. I want to show you something right here. Look at this type. It's called app user. I use an app prefix for the app models. Now, this type represents what a user is at the application layer. You can see that we have JSON tags here as well, because at the app layer, we're marshaling in and out of JSON, and it's fine to have that sort of knowledge there in the app layer. But I want you to look at the type system right now that we're using for the fields. I want you to notice that they're all based on the built-in types. Strings, excuse me, strings, byte, bool, there were integers, there'd be ints. We're using essentially the scalar, the built-in types, the raw types related to JSON. Now, why are we doing that? There's a couple reasons here. One, this is how the data does comes in this form. And two, ideally here, what we're trying to represent is that at the app layer at this point, all right, this data can look like just about anything that is passed to us. We're not going to fail here in any sort of JSON unmarshalling way. Now, that's not necessarily a type that gets passed in for an API call. Here's one that does. App new user. Notice we've got validation tags here. So we're using a third-party validation package that's capable of doing the data validation against this. And another reason to do this is depending on how sophisticated your JSON package is. The standard library JSON package is not really good at reporting unmarshalling errors. It's actually pretty bad. It's almost like they started coding it and they stopped. And so I want to make sure that if somebody doesn't pass a role, I could properly say, hey, you haven't done this, and not rely on a JSON package to do that. I'm going to rely on a validation package. So the last thing I really want is a JSON package failing things. I want that raw data coming in. And so you see it, right? There it is. That's the raw data. Now, anytime you use one of these built-in types, what I want your brain to think about is this model is saying that the data can be anything. It can be anything that there's no restrictions. There's no business rules. There's nothing. There really isn't from a type system. At the app layer, we're applying it this way. But I want you to now look at what the business model is for this same sort of data. All right, so look at the business model. In fact, I'm going to bring this in real quick so you can kind of look at both at the same time. So look at the business model there on line 24. What do you see? You see that we now have a different sort of type system for this struct, and there's no tags at all. So what is this model at the business layer saying? This model at the business layer is saying that an ID can't be just anything. An ID can only be a UUID. Same thing with email. It can only be this address. Same thing with a role. Same thing with time. That it just can't be anything that has to conform to this. Now, I keep telling you, by doing that, we're getting this compiler-driven sort of trust that validation has happened. Why? This is how. Remember, the app layer gets a string, but the business layer needs a UUID. There's only one way to make that happen. Only one way. You have to call a parse function to parse the string into a UUID. And if that parse function being called in the app layer fails, well, you just force the app layer to have to do the validation, that marshaling, right, between one to the other. Same thing with an email. Same thing with time. All of these packages have a parse function. And what we're doing is we're forcing the app layer code to have to call parse in this case in order to give us a data model that we know validates the data, because it's no longer just a string, it's a UID or an email address and such. Now, I want you to look at this role here. A role could have been a slice of strings, but I wanted real restrictions on what a role was. And I want to share with you a pattern that I use for this. And by the way, if suddenly I wanted some sort of rules around what a name is, I would define a type called name. And I would have a parse function. And I would make sure that the app layer had to call that in order to be able to validate that when I get that name, it follows all the conventions. So what I'm going to show you works whether you're dealing with maybe a set, like a role, or maybe something like a name that might be based on a regular expression or some other rules. Let's take a look at role. Now, by the way, this idea of having the type system in the business layer be more specific about the data it wants as opposed to the app layer is not a unique idea. It's not unique. I've seen talks and other people apply this idea, but I see a lot of mistakes in the mechanics of this, and that's something I definitely want to share right now. So look at role for a second. Here's a mistake that I see quite often. Somebody wants to define this type role, but what happens is they use an underlying type of string. This is bad. Don't do that. Don't do this ever, especially in these types of situations. Why? Because you're not getting any compiler protections when you do that. In other words, I could still write a function. I could write a function that takes a role, all right? But if I ever call Bill with any string, the compiler will allow that to happen, all right? The compiler will allow an implicit conversion of a literal string if it matches the underlying type of a name type. There's no compiler protection here. This is absolutely not what I want. You don't want the ability of an implicit conversion. So this to me is the strategy. We don't use an underlying type. We use a struct. By using a struct, no longer will the compiler ever allow the implicit conversion from essentially string to, in our case, a UUID, because the UUID isn't a type with an underlying string, it's a struct. And so we're going to start with that idea of a struct. And you can name that field anything you want. Value, I say name, it's really irrelevant almost because it's unexported. Once you define the type, then you define a parse function. And that parse function has the logic to determine whether the string being passed matches the criteria for something of this type. This is how you do it. All of these other packages, the UUID, the mail, the time, they all have parse functions. Follow this convention. It's a great convention. Now, role isn't a name. It wasn't trying to just follow some like, it always has to have an uppercase, always got to be greater than 3, or whatever the rules could be for a name. I wanted a set. This is how I do sets in Go. I define a set of exported variables based on a type of that, in this case, role, admin, role, user. I define a map of that set, and then I do the map lookup inside of parse. Boom, there you are. Now, I've seen people say 2 things to me on this. One, Bill, you're declaring exported variables and somebody can change that. So here's my answer to that. If you are changing these variables, then you get everything you deserve for doing it. I'm not going to protect you from yourself. So forget about that being an issue. We use exported error variables all the time in Go. So to me, that's not a problem. Bill, this is a map. Isn't that expensive? Maybe we should use a switch case. The map, first of all, is 01, based on how they handle the key. And I promise you, if your Go program isn't as fast as it otherwise could be, it's not this map. So let's walk away from that problem. The only flaw, if we want to call it a flaw in this implementation, and there's no way around it, is that you could construct a zero value role and pass it around your program. And if that was really an issue, then we could add a method like is zero or something, and you could put a little bit of logic inside your app. It has not been an issue for me. The only other thing I would say to you that you need are these two, other than you need a function to get the value out or a method. You want to implement the unmarshaled text interface, which is used by JSON and all the rest of them. That way, when you're marshaling your models, those marshalers and unmarshalers can execute this behavior and you're good. That's essentially it. This gets really boring because you copy and paste this code and you change it up into whatever you need. The difference might be whether you're using a map or you're using a regular expression or some logic. So that's it. That's your role. If I wanted to apply something to a name, I would define a type name, or department, I would define a type name department. And now I'm forcing the app layer to perform a parse operation. And that's giving me the guarantee at the compiler level that data validation has occurred. You'll see the same thing at the store level. Here's the model for the store. Look at the tagging system. It has a different tagging system. It's DB. Look at the slice of string here. It has to use this type. Look at department. It can be null. And so you need every layer to have its own model, so you have this sort of flexibility. And a change in a data model in one layer doesn't have a cascading breakage chain across the whole thing. I mean, imagine that the app layer was using this model, sorry, this one here, and somebody changed the business layer. Now you just broke everything going on in the app layer. You can't have it. These layers, I want you to think of these layers as creating firewalls between the different parts of your architecture. And it's the data models that are that sort of gatekeeper to the firewalls. So we want that. Now, also notice one thing, no tagging system in these models whatsoever. If I saw a tagging system in business layer models, it would pause a code review and I'd want to know what's going on here. You know, the business layer has to really be neutral between how data is coming in and out of the system and how data is being persisted. So it should be really neutral. Okay, so that talks about at least how data can flow between the different layers while getting a guarantee that data validation has happened. So in this particular case, only the app layer would ever need to make that database call, and that data can come all the way through until eventually the storage layer would, hit its database again. Now we've got efficiency between the different layers, and we have this idea that we can trust each layer in doing their job of data validation because the compiler won't allow you to make API calls across these layers unless you've done it. Beautiful. Okay. And like I said, every project should have these two things at least. Good, strong, package-oriented design, and at least 2 to 3 layers where data is moving. That's the data-oriented design aspects of this architecture. Where data is moving, data is being validated, and we get that sort of efficiency. Now, let's talk about where the domain-driven stuff can come in. Everything that I've talked to you so far about in this talk has been about how do we create firewalls between the different parts of our program and how important that is. We didn't go deep into how packaging does that, but it's there. We've started to get into how these project layers are doing that. But there's another set of firewalls that we can create in our architecture when it is important to do so. In my case, again, I'm working with a team of 3 or more people. This code base is either going to be handed off to someone, or at some point I'm going to come off this project and somebody new is going to come on this project. This is when I think you need this third layer of firewall. This is one way to do it with domains. It's not the only way to do it. I'm sure you could sit there and think about, well, Bill, how else can we create a third layer, a third dimension of firewalls? You could think about it. I'm going to share this with you. And I'm going to share with you how these firewalls work and some of the complexity that it brings. If I haven't said it already, domain-driven design adds complexity to your project. And I'm trying to reduce complexity. So again, you only want to add this complexity because you need it. Only add complexity when you need it. And right now, I'm not going to be trying to solve a technical problem. As far as I'm concerned, domain-driven design doesn't really solve a technical problem as much as it solves a people problem. It solves not performance in terms of your code base, but performance in terms of how fast you can move, building out new features, and how you can isolate team members from each other so we can minimize cascading bugs as well. So let's talk about that part of this architecture. Now, if we go into the business core, you see packages there, specifically home, product, and user. This is data that we're needing to manage for this product or for the project. We've got users, we've got products that we're managing, we've got homes that are owned by users and products that live inside of homes. You start to think about the data. There's a great quote around data-oriented design that says, if you don't understand the data, you don't understand the problem. All right? But let's just start with these three pieces of data. In fact, I would call these our domains. And I always like to start granular with the domains. And then if we need to sort of build larger domains, you'll see that in a second. So these are our three domains. We've got user, we've got product, we've got home. And here's the idea. The domains, like user, they create a vertical firewall within the scope of our project. Packaging is creating this lowest level of firewall at the API level. Layering is creating this horizontal set of firewalls where data is marshaled and unmarshaled across. And then domains create a vertical firewall, which to me create these sort of lanes of development where we can isolate developers from each other to work on each of these different layers. So at the simplest level, if we're thinking about CRUD, create, read, update, and delete, we could think of the following, right? Some sort of API call is made into this app layer because let's say we want to add a user. So some handler is called, right? Goes through the data validation, and then what happens? We call into some sort of business layer API, and that in turn does its thing, which is going to call into some storage layer API, which will eventually, and its job is to hit the database and say, do that storage. Now, I want you to think about something here. Ideally, anything related to user could be completely isolated, not just in the scope of our Go project here, but also within the scope of the database, couldn't it? I mean, think about that. And part of domain-driven design is to have this belief system that each domain not only has its own lane, but it has its own database, its own physical, unique instance of a database. And you need to keep that in your head. So again, that was creating a user. But if we're going to create a product, then the idea is all that code stays in its lane. And again, it has its own database too to do its work. And I can get crazy here and say once again that, well, if we're dealing with homes, we're doing it again. This is pretty cool, right? I mean, think about it. I could have Martin working in the user domain. I can have Gianni working in products. I have Dave working in home. And they're not stepping on each other at all because they're working on their isolated packages within the scope of their layers. They're even working on their own databases. And they're making sure that when you create, update, and delete and retrieve user prods or homes, that that's done within the scope of these sort of firewalls. Pretty cool, right? And so at a first level, I want you to think of this domain driven as creating these firewalls vertically between the data that you're managing. Now, I told you this adds complexity, and I want to sort of introduce some of that complexity now. Let's do it by some real world scenarios here. All right, so let's say Kevin's working on the product domain, and there's a front end to this, some sort of React front end app. And part of the React app is to pull back a page of products in the system. And imagine there's millions of these products. So paging has to be done at the database level. There's no way around it. So no problem. Kevin writes a handler to be able to query back products and does that work within the scope of this domain. And when we look at the product model, here it is, all right? This is what the front end gets back. Beautiful. In fact, we really should be looking at it not at the business layer so much as at the app layer, because this is really what they get back. Now, the front end dev writes all this code, and they publish it maybe on a staging system. And now the client turns around and says, this is great, but I have a problem. You're only showing me the user ID. I mean, that's the data that we're storing in the product system, just a reference to the user ID. That's not enough. I need to see the username. Now, Kevin's first reaction is, we don't have the username in our database. We just have the user ID. But Kevin's like, no problem. This is not a big deal. What I'm going to do is I'm going to define a second. I'll define a second model in the app layer, and I'm going to add name to it. And then what I'm going to do is after I get back that page of products, I'm going to have the user ID. So I'll just call into the business layer for the user domain and extract out those names for those user IDs. The app layer can do that. That is absolutely not a problem, calling into the different business APIs, because these business APIs exist within the scope of our running program. Now, people, I would say early on, when you thought about domain driven, this really started to become microservices, right? Like early on, people went microservice crazy. They're like, well, why don't the user domain have its own microservice, and prod have its own microservice, and home have its own microservice, and then this could be a gRPC call, and that's how people were building systems. I don't want to do that. I want to have these firewalls in here, but they don't have to be process bound. They can be in process here, like we're talking about, with a little discipline. And what this does is it allows the handler for prod doing this query to call into the business API to get the data. It's beautiful. Kevin does this work, and now the front end gets this model, and it all works. Brilliant. And we haven't done or broken our architecture. Everything stays clean. The worst thing that we could have done, the absolute worst thing, would have been to change the query here to do some sort of join. But remember, you can't do a join because in our belief system, each of these domains have its own running instance of a database. That's not even an option. Okay, we solved that problem. But here's a new problem that's about to come into play. They're real happy with this now. They can page through 1 million products. They could see the user for each one. And then they come back and they say, Bill, it's on me now because Kevin said I can't take this anymore, walked away. So it's back to me. They say, Bill, this is nice, but I need to be able to sort and filter on name. And now I'm like, we got a problem, because this is really the data that we have in our database. I mean, I merged the data by doing some queries, but unless name is actually in the database, I mean, the username is actually in the database, I can't do any sorting or filtering. And you know what the client says is, that's your problem, not mine. This is what I want. Okay, so how do we do this? There's a very complex way to do this. And then I think there are reasonable ways to do this. And when it comes to my friends who want to implement domain driven in a very pure way, this is where they start to get upset with me. How to do bi-directional, we'll talk about all that in a second. Let me continue down here and then we'll talk about some of that. Let's try to solve this problem. This is a big problem. I need to be able to sort and filter on username, but the username information isn't in this domain. Now, if you want to be very, very, very pure, how do you do that? Well, first thing we're going to have to do is define a new domain. We're going to have to do this anyway. Maybe this is called the user prod domain, all right? And the idea is, since every domain needs its own database, we need a way where anytime a new product is coming down this pipe, it somehow gets stored not just here, but also here. How can we do that? Well, one way to do that, potentially, is to maybe build an event system sort of in prod here. Now, we could do this. We could build a sort of an event system. And what we could do is have our package here somehow subscribe to events. So what's going to happen is that when a new prod is going down this path through the domain, it can fire an event that would then allow, let's say, the storage of this, obviously through the storage API to make that happen. We could implement an event system. So at that point, this could get the event for the new prod. Obviously would have to come back over to the user to get the name, and then it can store it. You can do this. This is what I've seen a lot of domain-driven people talk about. This scares the hell out of me. This is super complex. And if you make this asynchronous, well, now if it starts to fail, what are you going to do? How are you going to debug that? How are you going to track that? How are you going to know what's happening? It can work. And if you truly, absolutely must have separate databases, I don't see any other, well, there are other ways around it, but it's a solution. So Bill Kennedy doesn't want to do that. I don't want to add in that layer of that. I love that question. I will get back to that, I promise. There are rules around that, Demas. I will talk about it. Let's continue to try to solve this problem first. So I don't want to overlay an event system where I'm going to have data duplication here and have to deal with the fact that if that fails, how do I debug and manage that? So then what can I do without breaking the architecture? Well, this is what Bill Kennedy wants to do. I don't want to break the architecture. At the same time, I want to keep things as simple as possible. So this is what I'm going to do. I'm going to have a single database for everything. However, I'm going to extend the domains inside the database. Now, you could do that in a couple ways. You could use schemas and define a user schema here and say, okay, if your database supports schemas like Postgres, you could do that. Or what you can do, which is what I tend to do, is I just prefix each table with user, right? So you've got your user table, and then maybe you have a user something table. And all the tables within the scope of the user domain prefix with user. You could do one or the other, whatever one you feel works best for you. And so we create or extend these domains into the database. So at the end of the day, we're only all talking to one single database instance. Now, how does that solve this problem, Bill? The way that solves that problem is, again, if we're using like a SQL server here, all these SQL servers have something really cool called views. Stuff's been around for almost 40 years. So what I want to do is say, look, I can create a view that has the data blended from everything that's prod and the one name field. Now I've got a complete data table here that I can now do sorting and filtering on. So essentially, when that screen that we've been talking about needs to query products, needs to sort products, needs to filter products, I'm not going to go down the products domain. What I'll do is go down this domain here. And we'll go down the user prod domain, because the user prod domain has all the data we need to do that view, to do the sorting and do the filtering. In fact, this works out really well because none of my architecture between app, business, and storage breaks. The rule here is that you cannot write any queries that join data across domains. You are not allowed to have a single query here that would join data across domains. We're not breaking that rule because we're having the database do the join and by presenting a view to us. And so if one day we really did need to have a separate database for something, we don't have to change any Go code. We just have to figure out how that data gets there. And there's other database technology underneath here, or we build services underneath this line that maybe create these views in separate databases. That's how I would do it. I would never overlay an event system inside this project to produce this view. I would be producing this view outside of the project, whether we can do it with the database or we have to do it in other ways. Now, what's really nice about this is it starts to solve other problems that slow down projects. CRUD, though tedious, can be done fairly quickly. What I have found on these products is reports are a total nightmare. And everybody wants a new report that looks at the data a little differently. And so what's really nice about this idea of domains is that if you're being bombarded by reports, like, hey, I need a report that does this, right? And the data model for this report has to be different. Well, guess what? We could just continue to go ahead and build different domains for the different reports that we're going to be building, again, across these different sort of views that we're going to have to build for these domains. If we already have a view that satisfies what the report is, we could stay in that domain. We could build out that API. What's also nice about this is we could throw people at this problem now. I was in a situation where we were coming to the end of the stretch and they dropped like 10 reports on us where there were like 3 classes of reports that needed its own sort of data model. I was able to throw people at those report classes by building these vertical sort of firewalls and domains, and we were able to get these reports done really, really quickly. You know that the joke is always, hey, if I give you another person, can we move faster? And the answer is always no. They're going to slow me down. With domains, the answer could be yes. I could move faster because I could isolate this person through there. Tim, never ever use ORMs. You want to own and control the queries. That's where your performance is going to be won or lost. If there's bugs, you want to isolate query bugs to just that function. ORMs do too much abstraction. And again, you cannot have joins in here. You can only join against tables that are part of your domain, only that are part of your domain. So either within the scope of that schema or the scope of that prefix. You never want to join across domains ever. The views are doing that for us here. And you're keeping your architecture here super clean. You need to know what lane to go down for the data that you want. You start doing joins here from prod to user, it gets very confusing about what domain should I be using to get to this data? The moment you're like, I don't know what domain to use, things are falling apart really, really quickly. So keep these lanes, keep these domains to just the data for that domain specifically, and you can use views down here or other mechanics to build out these tables that do the joins. I want the joins across domains to be outside the scope of this architecture that we're building. This is how you keep this clean. What's also nice about having the one database is now we can also do transactions. So we could do now transactions across domains within the scope of our project because we have all of the data in a single database. It's a matter of now you can lay in, and this code has it, transactions that go across the domains. Okay, the key again, the key will always be these lanes have to maintain their purity. Storage layer queries can only talk to data within the scope of their domain. Never cross. You can have a single database. You extend those lines, and if it's SQL or like a Postgres or a SQL database, you can leverage views to do those joins. Keep that architecture super clean. Now, there is a couple of questions that were interesting here. I'm going to work them backwards. How do you know when a domain can talk to another domain? Because Go would never allow this, right? That's a cyclic import. So how do you know what the rules are for one domain, say business package, being allowed to import another domain's package? Remember what I said before? If you don't understand the data, you don't understand the problem. If you don't understand the data, you don't understand the rules for this either. I want you to look at the model for product. Let the data be the guide. Since product has a foreign key to user, that means that the product domain can import the user domain APIs. Since home has a foreign key to the user, it can import the user domain and make those calls directly. However, look at the user model. It doesn't have a home ID, doesn't have a product ID. Therefore, it is not allowed to import the product package domain APIs. It's just not allowed. So looking at the data, since the data drives everything, we would allow this, and we'll have no import issues whatsoever. App layer can call into anything, but inside the business layer, we need to have these rules. Now, what if this business API did have to make calls to prod and home? Here's an example. We're going to delete a user. The delete for the user is going down this path, okay? For sure, it's going down this path. We're going to delete. Now, we have a problem with delete, all right? If we delete this user, we should delete all its products. We should delete all its homes. But the call is coming down this domain. It's coming down this lane here. And this business package, the user one, is not allowed to import these. So how can it call into these domains to tell it to delete things? All right. We're going to go back to this idea again. But we're not going to do it in an asynchronous way. We're going to do it in a synchronous way. Let's go back and add what I'm going to call the event system, where we're going to use it to be able to make indirect calls across domains when we are not allowed to import that business package API directly, like in this case. So this is what's going to happen. Prod is going to write an event handler that will delete prods based on a user ID. It's going to write an event handler here that can delete homes based on a user ID. And when the call to delete comes through, this will make these calls synchronously, but indirectly. Let me show you mechanically how that's sort of set up. So In every one of these core business packages, you will see an event.go. On the user side, what we're doing is defining an event type. In this case, it's not on a delete, it's on an update. And what it says here is, I've got an event type, got the string method, and I can marshal, all right? And it's based on an event update user. Now, if you go to the product event, what does it do? It registers an event into this event core business package, which I'll show you in a second. And it says, hey, for the user domain, on an event updated, execute this function here. Execute this function. So product and home register a function to be executed from this source and this event. Now, let's take a look at the update call. Here's an update call in the user path. It calls into the database to update, and then it says, execute any function that's registered itself for this event. There it is. Execute any function related to this event. And there's no go routines here because I'll lose my mind. We essentially walk through the domain map, we walk through the event type, and for every function that we find, we execute it. There it is. Doesn't have to be asynchronous. Doesn't have to be go routines. Can be part of the same sort of execution path that you're seeing here. What that also means is that we can apply transactions to this as well with no real problems. So there is rules for when a domain can import another domain's API directly. That's based on the data. And when it can't, then you need these ways of doing these indirect calls. I call it an event system here because we can use it for events. I kind of don't like the name. I've been thinking about how can I get rid of the word event because there's a stigma to it, and maybe just call it indirect, right? We'll make an indirect call across these domains in a synchronous way. That's really what we're trying to do there. Now, I guess that answers the bi-directional sort of stuff. It answers the answers bi-directional. It answers the calls between. I've answered the ORM. But here's some registered functions for this could have succeeded and one. Yes, they could fail. And because I'm not doing this asynchronously, go back here for a second, I could get the error back and then fail. That's the beautiful part here, that I'm in line on this call, and now I'm making these API calls across the domains. I'm making them synchronous, and if they fail, I could get the error back and then operate accordingly, including some sort of things like if this was a transaction, roll back. You can do things at the database level if you want as well. And Martin, for sure, I would tell you to put those safeguards in if they exist. But remember, part of the architecture also is believing that each of these domains have their own database. And just making sure that all the code you write within the scope of these three layers don't do anything to violate that belief system. I've had people on my teams yell at me, Martin, because when I define my schema for the database, like you'll see here, they're like, Bill, why are you defining the foreign key relationship? You know the data really only exists in its own database. And I'm like, yeah, you can have that belief system all you want, but I have an actual database here, so why wouldn't I do it? But remember that if that data ever does get broken out into its own database, which we can do, our architecture doesn't eliminate our ability to have that flexibility, then some of the things you're talking about, you've walked away from. So definitely use it, but I would call it a second tier safeguard, right? For now. But my big thing is don't go routine crazy here. Keep it synchronous. You would have made it synchronous anyway if you could have imported the package, and you can't. So just keep it synchronous, and you can get back the errors. This is me going back to that idea, remember, of keep things simple until you can't. Domain-driven design can add a large amount of complexity very quickly when it starts coming into these problems. Keep it simple until you can't. And these are the techniques that I've found to keep the domain-driven side of things simple. Single database, even though we still isolate the database level, using views to do those joins. And here's another thing that we could eventually do as well. At some point, you know, your writes get super, at some point you have a system that's either heavy write, heavy read, or both. And the moment that you've got one or the other or both, you tend to want to separate your databases where one is optimized for writes and one is optimized for reads. What's nice about this architecture is that it lends itself to that, where eventually you could decide to have a second database, or maybe you're leveraging something like replication. And these domains, right, these domains are hitting the read-only database optimized for reads, and these domains are hitting the database that are optimized for writes. And remember, you do that, and you don't have to change a single line of code here. All you're doing is changing where that connection is coming from. That's why I'm so sort of like hung up on not doing anything that would cause you to make code changes here. Try to do that database work down here. Try to do it down here. And if you do that, then we know that Go code doesn't break regardless of where the data is. Who is responsible if a table schema changes? Yeah, so that's going to be breaking storage level code here, right? You changed this view, this model changes, that model has to change. Now, when the model changes, by default, nothing else breaks. The old data can still be flowing, because at the end of the day, what you have here are what I call two functions that you're writing. We do everything with two functions. The idea of the two function is to describe what the data is being converted into. And so the two function, it says to core user, essentially given a DB user, how do we unmarshal that data into a user? I can change the DB user model, and this is the only code that would necessarily break. Now, if you need that new field in all three layers, now you're going to go to all three data models. You're going to make those changes. You're going to change the two functions, and you're done. So we isolate it to the data type and the two function, and we've minimized the cascading effect of that change. And that's going to happen over time. Migrations is an entirely different sort of conversation to have, and how you do that, how you manage migrations. But ideally, because of the type system that I've talked about, it adds huge value when the data is changing. We change it one layer at a time, and we control the breakage as it goes. Last thing again, not every project needs domain. Not every project needs this third dimension of firewall. This, for me, is super important when you have more than one person working on the project, and this project has to be maintained by others over time. Then I think adding this little bit of complexity is worth it, because this is something that everybody can maintain, minimize that breakage, reduce some of the complexity in terms of people management, and the system can grow. So we got a full implementation of this here. The hour's up here, but at this point in the class, we'd start to go really deep into the implementation and recreate it by hand. But hopefully, this gives you some ideas for some architectural stuff that you're doing now and thinking about the firewalls between the different parts of your program. Think about how you're leveraging packaging. Think about how you're layering horizontal layering. Think about if you're even doing vertical sort of layering, how all that's working. Hopefully this gives you enough to kind of chew your brain around some interesting architectural ideas.
Yeah, thank you. Just want to give a short round of applause. Yeah, thanks, and thanks for the talk, and thanks also for the whiteboard plugins, really useful. And I think we had a couple of questions, but you answered a few of them already. I just want to go ahead and ask a few more questions on record, and then we stop the recording. So I did not have a lot of contact with domain-driven design, but if I had contact, and I kind of heard a little bit out of your talk as well, people can be very purist. It can add a lot of complexity. So is there a boundary for the kind of projects you mentioned that like in your last sentence, but like CRUD projects, larger teams, anything else that you would delineate, like, okay, let's do it this way, or do it another way? Because interestingly, I found like a couple of examples trying to do DDD online, and they all don't look like idiomatic Go code to me. Like you add like, you know, hundreds of files, and it looks like much more pain than it seems to solve. So yeah, do you have any other like delineations, like this is an infrastructure project and we do it like, you know, a bit differently, or this is CRUD and CRUD is mostly DDD?
If you're dealing with just a really simple data model, you got one or two tables, probably overkill. If you're dealing with a data model that is extensive like this, users, products, homes, sales, there's reports, there's all this stuff. These vertical sort of firewalls, they can become almost critical to your productivity. Again, this is solving human productivity problems. So if you're finding yourself not being as productive because somebody's waiting on somebody else, somebody can't move forward because they're waiting on somebody else, then you might need to start considering these vertical sort of firewalls in one way or another. The only technical problem this can solve is if you decide that there's a domain of data that's just growing so much out of control, you truly need to isolate its storage, truly need to isolate its management. This will allow for that, right? I would start with the single database, but if we decide that products was totally getting out of hand and I didn't have any transactions related to products, there's nothing stopping me from just loading another instance of a database and changing this line here. If we keep to the purity that this actually exists, whether it does or not. All right. Now, Gianni's right. CRUD in and of itself is tedious, man. It is tedious. So I want to show you a couple of cool things that I have in this project. If I didn't break it, because I've been updating this project for 1.2.2. So if this breaks, then I apologize. But this is tedious stuff. So I've done a couple of things here to help with the tediousness, things that I've been experimenting with. One is documentation. I wrote a little CLI tool that uses the AST package to generate docs. You will not see any comments in this code related to documentation, but watch what you can do when you have policies and standards in the code, where things go, how they're written. This is all driven by reading the code with the AST package. Every single API, output models, error models, it's super cool.
We don't see the browser. Maybe it's in a different window.
Oh, you don't see the browser? Hold on. Oh yeah, you don't see the browser because it is in a different window. Hold on. This is all by reading the code because there's consistency and standards in the code on how we do things. How cool is this? I hear project after project complain that they don't get documentation, or you have to use Swagger, and now you got to add extra comments. You got to add extra notes. I was like, there's got to be a way to do this without that. Here's an example. Now, go back to Gianni's sort of thing. This is a lot of boilerplate. There is a lot of boilerplate with CRUD type of work. So here's another tool that I've been playing with. It's in the sales admin tool, and it's called domain. And what it does is I've defined a set of templates with the core boilerplate in it anytime you want to add a new domain. All right. And then essentially, you can call that tool, I gotta find where it is in here, but you can call that tool and it will generate all the base code files for you. Oh, here it is. Like, let's say I want to add a sale domain to this. All right. Let me switch to. So I could run this tool, domain sale, boom, just added a bunch of files based on those Go templates. Again, some stuff is broken because I'm playing here. But look, here's your sale domain. Now, the cool thing, Gianni, would be, and I'm not there yet, is the stuff I'm playing with, where when you run this tool, you give it the data model. And if you were able to give it the data model, then it could take this boilerplate code and give you a better, a more complete data model and apply that everywhere. So again, when you have a project that's layered with consistency and rules and policies, then these types of tools that I'm showing you, and they're not trivial to build, but they can be built, and you have it. So the doc tool to me is the coolest thing. This new domain tool I'm just starting to play with now. What's nice about this code is it's not a framework. I call it a starter kit. Anybody can use it, rip it apart, and put it back together again. You got essentially everything you need to build production level sort of code, and then make it your own. You own the whole stack. It's not like you own a small part of it. Anyway, yeah. Cool stuff, right?
Yeah, wonderful. Reminds me of a talk that we had a few months ago where basically an AST-driven kind of monitoring could be set up also on the Go programming language. So that's a really powerful idea. Any other questions from the audience? I'm just like talking away. So I'm just asking, anyone else has, or comments?
So just take this talk for what it is and think about what you're doing in terms of architecture and the firewalling and packaging and the vertical and the horizontal sort of layering and firewalling, and just think about this stuff and see if it resonates with you or it doesn't. You're probably doing similar things in different ways, and it's just a matter of maybe formalizing some of it a little bit more.
Yeah, definitely. Okay, so if there are no other questions right now, I would just switch off the recording, but don't just drop out yet. So let me just stop the recording.